Okay, so let's take a look at the section 3.3 on annuities. This is a new term, annuity. Any typical annuity has two important elements. First element is regular payment. Second one will be the lump sum payment. So first element, regular payment. We also call it PMT. And second one is called the lump sum payment or one-time payment. Or one-time payment. If the financial instruments satisfy those two conditions, then we call this an annuity. First one, let's get to know a little bit more about annuity. Annuity definition is a series of cash flow for a fixed period of time. Each payment is for the same amount. Regular payments are referred to as PMT. And also the time between the regular payments is always the same. So think about the credit card. If let's say you have a credit card, you take out a loan from the credit card company. So at the beginning of each month, you will make a regular payment. We call it statement balance. You pay the statement balance. So that's how that goes. You always make monthly payments, right, for the credit card account. So two things. So satisfy all three these conditions. Each payment for the same amount. Regular payments are referred to as PMT. Time between PMT is always the same. And timing for annuity, we have ordinary annuities like saving plans, mortgage, and car loans. And then regular payments are made at the beginning of each period. The day you sign a contract, you do not make a regular payment. So the bank always give you a break before you actually start making payment towards your annuity. Okay. All right. So some of the examples of annuities. First one is a savings plan. So if you put away $50 in the bank at the end of each month for 50 years, how much will you have when you retire? What is the future value? Okay. So this is what they call the future value of the annuity. And also here the one-time payment comes in the future. That's why it's called future value of the annuity. And then also right here, we also call this you can also call this savings plan or retirement account. This is a typical retirement account setting. So you contribute fixed amount of money for the retirement account. You wonder what you end up with in the future. You retire. And secondly, if I want to be a millionaire, how much do I have to put in the bank at the end of each month? Right, so assuming this account generates interest, and this is also like, let's say you want to retire with $1 million, also could be set up as a retirement account. Also, we have a loan, periodic payments. If I take out a loan for 190,000, let's say pay for the house or pay for the car. So what is the monthly payment amount paid at the end of each month? So looking for the regular payment here, a monthly payment. It's also called a regular payment or PMT. So this is another example of annuity. Also, a trust fund. If I know the asset will give me $10,000 at the end of each year for the next 15 years, how much should I pay for this asset right now? Right. So this is what we call the present value. Annuity, because the lump sum, you have to pay for the asset right now. Okay, so this is some of the examples. We have two types of annuities. First one is called present value of the annuity, meaning the one-time payment comes at present time. So we have mortgage, first type of annuity. So when you apply for the mortgage, same thing for car loan, student loan. When you apply for car loan, student loan, once the agency approve it, then you have the funds, right? They will send you a check. Also, the credit card, it's also present value of the annuity. So you borrow money from a credit company to finance the purchase, and you make monthly payment to pay off the credit card debt. And then for the future value of the annuity, the lump sum one-time payment comes in the future. So a typical a future value of annuity could be a retirement account. So IRAs, 401k, 403b, those are typical example of retirement account in the current market. And again, all those one-time payment comes in the future. Once you retire, you start to withdraw from your retirement account. All right, so properties of annuities in the future value of the annuity, the lump sum payment, one-time payment comes after the regular payment. Also, the lump sum payment is in the future. Okay, so two important characteristics. Lump sum payment comes after the regular payment. So you keep contributing towards the annuity account, and in the near future, you withdraw the total amount from the account. So in the present value of the annuity, the lump sum payment, one-time payment comes before the regular payments, and lump sum payment is in the present time. That's why it's called present value of the annuity. So again, bank will issue a check before you making a regular payments, right? For example, like a mortgage, car loan, student loan, credit cards, they all behave a similar way. All right, so now let's take a look at the future value of the annuity formula. The future value equal to regular payment times square bracket over parentheses 1 plus annual interest rate R over number of compounding period raised to the NT. Number of compounding period times time T minus 1 square bracket over R. So right here, the F represents the future value of the annuity. R represents the regular payment, or you can also call it PMT. So if you want to use PMT here, that's okay. Also use PMT to replace R. And then lowercase r represents annual interest rate. Right? You can also view that as effective interest rates, right? The number of compounding periods per year, and then 20 timing years, right? So unit for T must be years. So this is the future value of annuity formula. Present value of the annuity formula look similar but not the same, right? So here we have a regular payment times square bracket 1 minus 1 plus R annual interest rate over N number of compounding period raised to negative NT over annual interest rate over number of compounding period, mainly used for the mortgage, credit cards, car loan, student loan. And P represents present value of the annuity. R represents regular payments of PMT. Lowercase r represents annual interest rate. You can also replace this uppercase R with PMT. N is the number of compounding periods per year, and T is time years. So the formula is slightly complicated, but once you get used to it, it's not bad. Okay. Now first one for example one, you save $500 a month in account yielding 5%. So saving $500. So this is a regular payment, right? A monthly payment. This is a monthly payment of $500. Okay, so we have R. regular payment for PMTI equal to $500. And then we also have an interest rate, it's 5%, and compounding monthly, that means N equal to 12. How much will be in the account after 10 years? So times. So now you're looking for the future value of the annuity because will be, right, indicated in the future. So we are talking about the future value of the annuity. We have two elements here, regular payment of $500, also the lump sum payment, one-time payment in 10 years. So future value of the annuity equal to regular payment times open minus 1 plus R within the NT 1 over R. So we know all these numbers. All we have to do is throw in all the numbers here. Regular payment $500 times 1 plus the rate is 5% over 12 raised to 12 times 10 minus 1 and over rate 5% over 12. So again, this is quite sophisticated. So we definitely need a calculator Excel to do this. I'll show you how to do this in Excel. So we just input it as this 500 multiplied by open parentheses of another parenthesis 1 plus rate is 5% by 12, 5% by 12, and raised to 12 times 10, 120 payments, right? So we're making 120 payments of $500 minus 1. Okay, that will be the numerator and divided by the denominator in parentheses 5%, 12. Okay. And once you input it formally, then Excel will give you the result, or your calculator will give you the result. So in 10 years, you end up with $77,641.14. $77,641.14. So now it's $77,641 and 77. Let's see, check. $41.14. And if you want to know how much interest, total return on this account, on this annuity account, total return, you could do, so you are getting $77,641.14. Remember, you are making $500 payment towards the account over 10 years, 12 times per year, that's 120 times. So multiply by 120. So we end up with $77,641.14 minus 60,000. So the difference is return on investment. Return on investment turned out to be $17,641.14. Okay. That is total return on this retirement account. Example 2, you want a retirement account to reach $1 million. So meaning you want $1 million in the near future. So this is the future value of the annuity, 1 million. How much should you deposit each month in an account yielding 5.44% compounded quarterly? So the rate is 5.44% compounded quarterly. That means 10.3. And reach this goal in 30 years, 20 years. So we know future value is $1 million. The only thing we want to figure out is regular payment. How much regular payment would you have to deposit each month to reach the goal in 30 years? So one more time, we use the future value of the annuity formula regular payment because this is a retirement account. 1 plus R over M to HE minus 1 over R. And here, let's throw in all the numbers first. It becomes a million on the left. We put regular payment, that's what we're looking for, plus the rate is 5.44%, plus 4 raised to 430. Again, it's 120 payments over R, which is 5.44% over 4. And now in order to solve this, I'm going to use a proportion concept. So on the left, make it over 1, right? Any number could be written as a number over 1. And we just do cross multiplying. So end up with R times the square bracket 1 plus 5.44% over 4 raised to 120 power minus 1. And on the left, on the right is a million times 5.44% by 4. Now all we have to do is get rid of the square bracket by dividing both sides of the equation by square bracket. Put the top in the parentheses, on the bottom in the square bracket. 20 power minus 1. We'll cancel the square bracket. Regular payment is by itself, and let's find out what the regular payment is. One more time, we will put this in the Excel result. All right, so here we go. We get a million multiplied by 5.44% over 4, dividing by parentheses 1 plus 5.4% over 4 raised to 120 power and minus 1. And we end up with let's see, it should be $3,351.28. $3,351.28. Regular payment is 3351. 140.28. So this is what the required payment is in order to reach $1 million in 30 years in this particular scenario. Okay, so the next step, a couple wants to buy a house and then they could afford to pay $1,450 per month to pay off the loan. Assuming the mortgage is a 30-year fixed mortgage with a 5% interest rate, how large a mortgage could they afford? So mortgage is what we call the present value. Because the bank will issue a check once they approve the loan. So you get a check right away at the present time. Using the present value annuity formula, first of all. And then also they could afford to make $1,450 regular payment. Here the R is $1,450. And then the rate is 30-year fixed mortgage. The rate is 5%. And it's compounding monthly because it's monthly payment. N equals 12 times T equals 30 years. So it's 30-year fixed mortgage. So for the 30-year fixed mortgage, meaning the monthly payment is the same over the life of the mortgage. And we are looking for the present value of the annuity. So the present value of the annuity equals regular payment times 1 minus 1 N T. Numerator divided by R over N. Denominator. Now once we know all 4 elements here, We plug in a regular payment $1,450. Putting the rate is 5% over 12 raised to negative 12 times 30. So we are making 360 payments here. And then the denominator is 5% over 12. And let's see what the present value of the annuity is. How large a mortgage could the couple afford? Excel to get a result. So right here we got $1,450 times 1 minus 1 plus 5% by 12 raised to negative 12 times 30. 360 regular payments over the life of the mortgage, dividing by 5% at 12. Okay. And once we input that, then we get the result right away. It's going to be $270,108.30. Right? That's the total mortgage they could afford under that given circumstances. $270,108.30. So the total is $270,108.34. This is total mortgage they could afford to purchase the house. Okay, example 4, house hunter find a house that requires $450,000 mortgage. Will be the monthly payment on 30-year 4.25% mortgage. Here, definitely we're looking for payment. Looking for R. And then mortgage amount, we know that the present value of the annuity is $450,000. That's what the bank will lend the house hunters amount. Guarantee that's 30 years. For compounding period 12, and then the rate is 4.25%. And one more time, we are solving for R here. So present value of annuity for regular payment times 1 minus 1 plus R N NT over R N. And we throw in the numbers first. 450,000 regular payment times 1 minus 1 plus the rate is 4.25% over 12 raised to negative 12 times 30 years. So they're making 360 payments, regular payments over the life of the mortgage. The rate is 4.5% over 12. Similarly, I make it proportion and cross multiplying. So this that go to the left. So R square bracket and this plus 4.25% over 12 raised to negative 360 power goes to the left. And the right is 450,000 times 4.25% at 12. Okay, and we just divide both side equation by square bracket. One minus 1 plus 4.25% over 12 raised to negative 360 power. On the left, we cancel this. So regular payment R is by itself. On the right, so we have 150,000 times 4.25% over 12 over the square bracket. So now go to Excel, putting that 450,000. That's a numerator, 450,000 multiplied by 4.25%, 12, and divide by 1 minus 1 plus the rate is 4.25% by 12 raised to negative 360 power. And that should do it. Here should be gone. Then once you enter, you should get a result and turn out to be $2,213.73. $2,213.73. So these are regular payments required for this particular mortgage. Now, consider two mortgages, each for $400,000, and so one mortgage is for 15 years, the other is for 30 years. Compare the monthly payments in this case, and we're going to figure out each one of these. Compare the monthly payment to amortize each mortgage, and then total interest paid over the life of the mortgage. We're going to consider 15-year mortgage. So for the 15 years mortgage amount is, so present value of the annuity is 400,000. Rate is 4.5%. Time T equal 15 years because it's 15-year mortgage. And the compounding period is 12. So again, we are looking for the regular payment. That's okay. Compare the monthly payments, right? Regular payments. That's what we're looking for. So present value of the annuity equal to regular payment times 1 minus 1. Wow. You can also make a proportion first, and then cross multiplying to get a R times. So we just work with this other variable term first before we carve out the numbers. And on the right is this goes here. On the right is P times present value annuity times rate over the compounding period. And from here, we're just dividing both sides equivalent by this by the square bracket. So we get a regular payment equal to P times R N. It's in the numerator divided by square bracket 1 minus 1 plus R over N negative N T. And right here, we're finding out the numbers. So the annuity is 400,000. The rate is 4.5%. The compounding period is 12. Denominator is 1 minus 1 plus rate is 4.5% over 12 raised to negative. M is 12 times time T, that's 15. So it's 180 payments here. So we put into the calculator or Excel, get a result. Excel, we got 400,000 multiplied by 4.5% by 12, dividing by denominator 1 minus 1 plus 4.5%, 12 raised to 180 payment because it's 15 years. So you can also do 12 and 15 plus parentheses. And that will do it. And so you just key enter, you get a result. So the monthly payment is $3,213. $59.97. So it's $3,059.97. $3,059.97. That's monthly payment. Now this is the monthly payment. And if you want to look at how much interest they pay towards the bank, pay the bank total interest. So remember, you only borrow $400,000, but on a monthly basis, you're paying $3,000.97, 12 times a year, 15 years, right? So it's multiplied by 180 payments minus $400,000 loan. And the difference is what we call the total interest paid. So now one more time, I'm putting Excel. So this is $3,059.07 multiplied by 180 payments because 15 years mortgage minus 400,000. And the difference is the interest paid towards the bank. Paying $150,794.60. So the mortgage is $150,000. $794.60. $794. So this is total interest, meaning bank will charge you this amount of interest. Now let's consider the other option, which is 30 years fixed mortgage. Now it's 30 years. So for 30 years mortgage. So now time t becomes 30 years. We still have present value, which is 400,000. Rate is 4.5%. And the compounding period is 12, and time t becomes 30. Alright, so one more time we are solving for the regular payments. So we do that right now. Doesn't matter. Annuity, the regular payment is compounding period, okay. So here you can throw in the numbers first. 400,000 on the left. Regular payment at 3,419. The rate is 4.5%. 12. There's another 12 times 30, so we're making 360 payments. So as you can see, probably because longer times and making less payments, monthly payments, they're paying off that over double the amount of time. That's a trade-off here. 3.5% over the immediate proportion cross multiplying, we get a 5 times 4.5% over 12 raised to 360 power. So we are making 360 payments. On the right is 400,000 multiplied by 4.5%. Now we divide both sides of the equation by the square bracket. Now we get a result. So cancel square bracket on the left. So regular payments by itself. Let's see what it is. So one more time we put into the cell. Okay, so this is this one is 15 years. And 30 years, we can put it side by side. 30 years, first of all, let's calculate the monthly payments. 400,000 multiplied by 4.5%. 12, and then divide by 1 minus 1 plus 4.5% by 12, raised to negative 360 power, and that should do it. The answer, you get $2,026 and 74 cents. As you can see, for 30 years, you're making less, smaller amount of a monthly payment, but the interest will be much more. Right? We will see that in a second. So, payments. This one, interest paid, total interest paid. Okay, so let's copy that first. $2,026.74. $2,026.70. That's a monthly payment. Now, total interest paid would be calculated. So, making $2,026.74 by 360 payments. Right? Over the life of the mortgage, 30 years, 12 times a year, 12 times 30 is 360 payments. But you only borrow 400,000. So the difference is the interest you pay to the bank. Let's see what that is. It will be a lot more. Right? So it's $2,026.74 by 360 payments minus the loan amount, the mortgage amount, 100,000. The difference is, as you can see, it's more than doubling. Right? So $329,626.40. Although the monthly payment is smaller, but the interest you pay to the bank is more than doubling. So this is a trade-off. You get a longer term, but you pay more interest, right? So that's the difference between 15 years mortgage and a 30 years mortgage. So the ending balance, total interest paid is $329,626.40. So $300,626.40. Okay, so this is the total interest paid, right, for the 30 years fixed mortgage. So again, these are all fixed mortgage. And those are the popular mortgage in the market right now. Question 6. Compare the financial condition of two workers. One starts to save money early for retirement, puts away $300 a month in a retirement account, paying an average return of 6% over 40 years. The other one starts late and put away $1,200 a month for 10 years in an account, also paying an average return of 6%. As you can see, the rate is the same. Now, the second person putting away 4 times as much money, but for a quarter amount of the time, right? Compare the total ending balance and interest earned for each worker. Since the retirement account, we know we're dealing with the future value of the annuity. So make sure you distinguish them because that's the most important thing. And you receiving the lump sum payment in the future. Right? And right here, we're going to use the future value of the annuity formula, but let's list all the given information here. So for first person, $300 first one. So the regular payment is $300. Time T is 40 years. Monthly payment amount, right? Monthly payments, 1 year is 12. And we also know the rate is 6%. I'm looking for the future value of annuity here. So regular payment the T minus 1 over our. Now throwing all the given numbers here. So future value. We're looking for regular $300 1 plus the rate is 6% over 12 raised to 4 times 40 minus 1 over the rate is 6% over 12. Okay. And now let's find our result, right? That is value equal to approximately equal to Excel, the result. So first person, second one. So for the first one, we have $300 multiplied by 1. This is 1 plus the rate is 6% by 12 raised to 40 years, 12 times a year, so 480 units. Minus 1 divided by 1 year is 6% by 12. Alright, so now once you enter the result, and that turned out to be $597,447.22. 597,000. The future value is $597,447.22. And if you look at it, this is total ending balance. And you want to know interest earned for first worker. So total interest earned. So it is getting this $597,447.22 future, but he's contributing every month, right? So $300 he's making 480 payments over the life of the retirement account. So the difference is the interest earned. Easy to find that on the Excel. Interest earned. First one is balance. Second one is total interest earned. So this would be $597,447.22 minus $300 times 480. This must be $453,447.22. $453,447.22. Okay. So this is the interest earned, total interest earned for first worker. And look like it's getting the most of the ending balance comes from the interest earned. Okay. Yes, so which is good thing. Let's take a look at the second worker. For second worker, he puts away $1,200, so regular payment is $1,200. For 10 years, 10 years, and for compounding period 12, and then rate is 6%. So similar condition, but again, it's turns slightly different. But let's see what the future value of the annuity is. The future value for the regular payment times 1 plus R over N minus 1 over R over N. Now one more time, we throw in the numbers. So 1,200 times 1 plus 6% over 12 and raised to 12 over R, which is 6% over 12. Alright, and one more time we put into the Excel. So the second person is contributing a lot more, right? 4 times as much. Multiplied by 1 plus 6% by 12 and raised to 12 times a year is only 10 years. 120 payments. That's numerator divided by denominator, which is going to be 6%, 12. And once you hit enter, you get a result. As you can see, it's a lot less. Right? Compared to this, it's 1/3 as much. $196,655.22. That's the ending balance. 6655 and 20 cents. And one more time, this is the ending balance. And as you can see, it's a lot less. $400,000 less. Total interest earned. This is balance. Total interest earned is ending balance minus contributing $1,200 by 120 times over the life of the retirement account. As you can see, it's a very little interest here. It's equal to $196,655.20 minus 1,200 times 20 payments, right? There you go. So we get a $52,655.20. As you can see, they are actually contributing the same amount of money, but the interest is so much less, right? So this is the hint here is the indication here is you should contribute towards your retirement account as early as possible. Just based on these two different scenarios, we know that contributing much less money for much longer time is so much better compared to the other contributing more money but less time. So, the time will give us a compound effect, and you end up with a lot more money. Right? So $50,655.22. All right, so definitely the first worker is so much better. It's so much better because he starts early and contribute towards the retirement account. Example 7, compare the total ending balance of the 20 years of monthly payments, $1,000 in two different accounts. One pays 5% interest, the other pays 10% interest. Now this is interest, so different interests also have different effect. So first of all, let's look at 5% account. So this is still dealing with the future value of the annuity. Still look like a retirement account setting. Because the ending balance is in 20 years. The 5% account, regular payment is $1,000. And 20 is also the same years. The rate is the same 5%. No, it's different. One is 5%, the other one is 10%. So now we're looking for the future value of annuity. So this is regular payment times 1,000 and 20 times 1 over our rate. Now throwing all the numbers here, so 1,000 times 5% over 12 raised to 12 times 20 over 5%. So the future value, let's see what that is. So this is 5% account. The other one is 10% account. 5% account, regular payment is $1,000. That's 1.1 plus the rate is 5%. 5%. 5% over 12 raised to 20 years. 12 times 10. 12 times 20. The minus 1 divided by denominator is 5%. That's 1. And that should give us the balance, which is $411,033.67. $411,033.67. Okay. And this is the ending balance for this 5% account. For the 10% account, okay, so similarly, regular payment is 1,000, and it's 20 years. Rate is 5%. Compounding period is 12. So the future value of the annuity is the regular payment over hour. So this regular payment is $1,000 plus 1% over 12 raised to 12 times 20 minus 1 over 5% over 12. Let's see what the future value is. So this is one more time 1,000 times 21 plus 5%, 12 raised to 12 times 20, 40 payments over the life of the account over 5%, 12. Okay, that's good. The ending result is, so it's 10%. So it's 10%. So it's $759,368.84. As you can see, 10% account yields much better return, right? $759,368.80%. 700. So yeah, this one should overlook 6 here. It should be 10% here. This is 10%. Okay, so then we end up with 759,000, which is a lot more. $759,368 and 30%. So 10% yields much more return. So 10%. It's 10%. 10% just give you a comparison. So when the rate is twice as much, you're earning much more interest, much more return on the from this account. Example 8. Trust fund is set with the goal of providing 30,000 semi-annual payments for 30 years. It's a bank in which the fund is created and guarantee 5.5% interest over the life of the trust. How much should be deposited to fully fund the stream of the payments now? This is present value payment because the lump sum payment must be deposited by now. So given the regular payment, $30,000. Alright, it's semi-annual, so then one period is twice. You're getting paid twice per year. 20 to 30 years. The rate is 5.5%. Okay, so looking for the present value of the annuities. Oh, over hour. Similarly here, so we solve for the P, so it's 30,000. 1 minus 1, the rate is 5.5%. 12 raised to negative 2 times 30 to the power divided by 5.5% over 12. So the present value annuity, so that is 30,000 minus 1 plus 5.5% of raised to 2 times 30 30 minus 1. So close parentheses divided by the denominator is 5.5% over 12. Let's do it. It's turned out to be you need to put in $1,570,585.06. $1,570,585.06. $585.06 to fully fund this trust fund. Alright, so this is a trust fund problem, and a lot of rich people set aside this type of trust fund to fund their kids or grandkids, education or future needs. And last question: suppose you win $40 million lottery, right? Lottery company give you the choices: 40 yearly payments of $1 million each, or equivalent lump sum payment now. The lottery company will calculate the lump sum payment based on 5.25% interest rate. How much will be offered now? So now, meaning it's looking for the present value, annuity. So you winning $40 million, you're getting paid $1 million for 40 years or equivalent lump sum. So now you want to figure out what is the equivalent lump sum payment. So again, regular payment, that's $1 million per year for 40 years. So times 40. Compounding period once per year, when you pay once per year. The rate is 5.5%. And based on this, we can solve for the present value. Anybody? One minus 1 plus R and 2. So the regular payment is $1 million times 1 minus 1 plus the rate is 5.5%. 12 raised to the negative 1 times 40. and that's going to be 5.25% over 12. And let's see what the present value annuity is into the Excel. So since you win 40 million, but you're not necessarily getting 40 million, right? Because every company will use the time value of money and discount that money into the present value. That's why you not end up with 40 million. Unless you take the other option, getting 1 million per year for 40 years, but most people will choose the second option, getting an equivalent lump sum, because it just makes more sense. One raised to 1 times 40, and dividing by it is 5.25% by 1. And that should do it. I mean, turned out to be you only end up with the $16,597,497 and then 78 cents. 16,587. $497 and 78 cents. And that is equivalent long time path, because getting 1 million for 40 years for most people is not a good option, because if you have 60 million and 597,497 go to market and find a brokerage firm, or like those firms which can give you a better return to 5.5%. And in 40 years, you end up with more than $40 million, maybe 50 million, $60 million. So you have more growth potential by finding a better brokerage firm out in the market. Okay, and that's pretty much everything in this section. You should definitely work on an assignment, homework assignment, to get better at this.